Three quiet shifts are happening at once. Image generation is moving from patch level to channel level compression. Video models are being aligned with real camera geometry instead of loose aesthetics. And feedback systems are learning to point to exact failures rather than blur them into heat maps. That matters because it means generative models are getting better at the three things engineers actually care about: representation, efficiency, physical control, and actionable diagnosis. Keep watching, because the details here reveal where the next generation of multimodal systems gets sharper, cheaper, and much easier to steer. Let's explore the first paper, channel-wise vector quantization. Channel-wise vector quantization from Shanghai Innovation Institute, Westlake University, Zhejiang University, Fudan University, JD.com, and the University of Chinese Academy of Sciences. Replaces patchwise image tokens with channel-wise tokens. Each latent channel becomes one discrete code word, and autoregressive generation is reformulated as next channel prediction rather than next patch prediction. The key result is structural, not incremental. CVQ reaches 100% codebook utilization with a 16,384 entry codebook, while conventional VQ collapses to 4.5% utilization at the same size. On ImageNet, 1K reconstruction vanilla CVQ improves RFID to 2.6 at 256 tokens and 0.88 at 1024 tokens, with PSNR rising to 25.02 decibels and SSIM to 0.723. The paper also shows that scaling the codebook to 65,536 entries preserves 96.1% utilization and reduces RFID to 2.32, a 52% reconstruction improvement over the VQ baseline. Built on CVQ, the channel-wise autoregressive model, CAR, is trained on 80M text image pairs and a Qwen 3 4B 8B backbone. The 8B version reaches GenEval 0.79 and DPG 86.72, while the 4B version scores 0.75 GenEval and 83.82 DPG. A simple, nested channel dropout scheme adds a coarse-to-fine ordering and boosts generation by 0.1, 2 GenEval, and 9.38 DPG without hurting reconstruction, indicating that channel tokens can support both efficient compression and strong text-to-image synthesis. Let's explore the second paper, Geo-Align Video Generation Alignment via Metric Geometry Reward. Geo-Align is a reinforcement learning framework for camera-controlled video retake built on the pre-trained WAN 2, 1, 1, 3B video model via redirector and optimized to follow novel camera trajectories without paired multi-view supervision. Its core novelty is a metric geometry reward. A frozen MapAnything 3D evaluator estimates rotation and translation from generated videos, then penalizes trajectory error with temporally increasing weights, so late frame drift matters more, while Video-Align and HPSv3 preserve perceptual quality. To solve the scale ambiguity of real-world camera annotations, Geo-Align fuses city walk conditioning videos with target trajectories sampled from OmniWorld and rescaled by truncated Gaussian sampling into physically plausible motion ranges. Training uses GRPO with mixed GRPO style sliding window sampling, group size, 12, 25 denoising steps, and 140 RL iterations on 64 NVIDIA A 800 GPUs for about 130 hours, updating only self-attention layers. On Davis, with the 10 Recam Master trajectory categories, the method improves camera control and visual fidelity over redirector, reaching transfer 0.0129 and Rotor 1.3645, while also raising Dyne, MET 3R to 0.8573, and ablation shows the full reward outperforms an aesthetic-only reward, reducing Rotor from 1.6082 to 1.3895 and improving MET 3R to 0.3082. Let's explore the third paper, Where, What, Why, and Important Structured Defect Grounding for Text-to-Image Feedback. This paper from Tsinghua University and Kuaishou's Kohlers team introduces Structured Defect Grounding, or SDG, a shift from heat map regression to instance-level defect prediction for text-to-image feedback. Instead of collapsing failures into a single score or pixel field, SDG represents each defect as a location-type reason importance tuple, covering both artifacts and prompt condition misalignments. To train and evaluate this formulation, the authors build SDG 30K, a 30,096 image dataset annotated across 4 generators: Flux, 2Dev, Z Image Turbo, Longcat Image, and Senna 1, 5 to 1, 6, B, and augment the labels with Gemini 3 Pro for reasoning traces, description, expansion, and importance scoring. A Quen 3 VL 4 B instruct detector trained with supervised fine-tuning and GRPO reaches 0.263 box F1 at 0.5 for artifacts and 0.387 for misalignments, close to the human upper bound of 0.278 and 0.409, while Zero-Shot GPT-5, 4, and Gemini 3 Pro lag far behind on precise localization. The structured outputs also drive BoxFlow GRPO, which turns defect boxes into importance-weighted spatial rewards for Flux, 1dev, and improves average downstream reward by 2.4%, with p-real rising to 0.228. The same feedback enables GPT image 1.5 refinement, where SDG beats Image Doctor and a fixed caption-only baseline on paired comparisons, showing that localized, semantically explicit defect grounding can diagnose, align, and correct modern generative models in one framework. That's a wrap on today's AI paper highlights. Thanks for watching.